All right, and so now at this point, after seeing quite a few examples on testing a hypothesis about a population mean value, then we are now ready to make some highlighted generalizations or some highlighted generalities regarding the key steps of to perform a test for a population mean value. And so when it is the step where we identify our alternative hypothesis, then the alternative hypothesis is always in the form of an inequality. And so throughout the examples, we have seen some alternative hypothesis stating that the mean value we're testing is less than a value claimed. Or we can see that in some testing hypothesis problem, the alternative hypothesis is stating that the population mean value is greater than or above the value being claimed. Or in another kind of problem, we can see that alternative hypothesis statements can also be saying that population mean value can generally be other than the value claimed. And so these are the three, and the only three common forms, the only three different ways how an alternative hypothesis can appear to be. So it can only be either one of these three different forms. And from any of these alternative hypotheses, it is now clear that the null hypothesis is always saying that the mean value as a claim right here equals the value mu sub 0. So mu sub 0 here is symbolically the symbol for a value being claimed in the null hypothesis. And so same way here, once we have identified our alternative hypothesis, then the null hypothesis can easily be identified as saying that mu equal that claim value. And the same way here, null hypothesis must say that mu is equal the value being claimed. And so now, from drawing as a generalization out from the three different cases that we saw throughout the different examples, then when the alternative hypothesis is stating that generally the population mean value should be less than this value mu sub 0 claimed in the null hypothesis, then the test like that we were doing is referred to as this is the case that we were performing a left tail test. And now I really write this terminology in red ink right here to emphasize the importance of the way how we use terminologies. And so further, in that similar way, now once we have identified our alternative hypothesis and it says greater than in our inequality statements, then this is regarded as a right tail test. And just like that, in some other examples where we've had that alternative hypothesis stating that the population mean value is just generally other than the value being claimed in the null hypothesis, this case here is referred to as, the test that we're performing here is being referred to as a two-tail test. And then in any of the three cases, in any of the three different kinds of tests that we are performing here, in the end we always going to need to rely on our sample mean value that's given. And we will rely on our sample standard deviation that's given. And a little further clarification here, the reason we rely to the sample standard deviation is because really throughout all the example problems that anyone have seen, we have always been having unknown actual population standard deviation, and that's the reason why we use S, the sample standard deviation, as a close enough approximate. And further, we use the given or the known sample size right from our sample. And from there, a key statistic value that we calculate is a t star. And so the rule for calculating t star is always the value of our sample mean minus the value being claimed in our null hypothesis. And the difference there is divided by a fraction expression, S over square root of n. And along the way, our sample will have a degrees of freedom. I call that df, being the sample size minus 1. And once we have identified the test statistics here and the degrees of freedom of our sample, then now that when it comes to being a left tail test, then we calculate the p-value by setting up the probability where we run into a sample mean value at sample size n right here to be less than or equal to the sample mean value we've had in our sample. And so this is how we're setting up our p-value calculation when we're working with a left tail. And so notice how being a left tail here leads to setting up the probability statements with a less than inequality. On the other hand, when we're setting up our p-value calculation for a test that is decided as a right tail test, then again it is a probability setup, but we're now looking for the probability where we find our sample mean at size n is greater than or equal to the sample mean value we have given. And so right tail must be consistent with the inequality right here being pointed to the right hand side. And when our test is a two-tail test, then there are two cases can happen. We will set up our p-value calculation as a right tail. So this inequality is for right tail, as a right tail probability calculation. If our t star is positive, but then make sure to multiply this right tail probability calculation by 2, because in the end it's a two-tail test. So again, two-tail test lead to a right tail probability calculation if t star calculation was a positive t star, and then at the end your final p-value must be the double of that right tail probability calculation. On the other hand, the p-value, the final p-value for a two-tail test will be calculated as a left tail probability calculation, so less than or equal to the x bar value given in our problem. But this case happens when or if our t star was calculated to be a negative value or a negative t star from this formula. And then again, the final p-value for a two-tail test must be the double of either the right tail or the left tail probability calculation. And in all three different cases, in any of these three different cases, the final p-value, as another key highlighted steps right here, must be, final p-value must be compare with the given significance level. So alpha throughout my examples is the formal symbolic expression for significance level. And usually it's given somewhere throughout the given problem. And then we can use that comparison here to make our final decision about strong evidence or not. So if p-value is compared as less than the significance level given, then as we have seen through the examples, that leads to having strong evidence. And on the other hand, if otherwise, if p-value that we have calculated, the final p-value that we have calculated, whether we are in a left tail or a right tail or a two-tail situation, as long as the p-value is greater than or equal to the given significance level, then we can say that the sample we have as the evidence is not strong evidence. And so this is the general structure of the highlights of the steps, how we performed testing a hypothesis about a population mean value.